this video, we're going to look at how we can set out all of your materials into the SigmaNest technology database and apply accurate costing. Once set, the material and cost can be applied to single parts, multiple parts, and to nested parts. This video will focus on a single part. Opening up the material database, you can see we've currently only got the default materials: aluminium, mild steel, and stainless steel. When we look at the material cost tab, you can see there are no costs associated to any of the materials. First, we'll add a cost for the mild steel. SigmaNest uses a cost of pounds per kilo. For easy calculation, I'll add a cost of £1 per kilo. This is equal to £1,000 per tonne. Therefore, if SigmaNest calculates the mass of the part to be 5 kilos, I'd expect to see a material cost of £5. Creating custom materials is easy using the copy material function. I'll add in a grade of S275JR. The information that I require is the material name, cost, density, and what base material it's linked to. This is so that the post-processor knows what speeds and feeds to apply. I've added a cost of 50p per kilo or £500 per tonne. I can repeat the same for EN1A with a cost of 75p per kilo or £750 per tonne, checking density and material group. Let's quickly add some aluminium. 6061 at 80p per kilo or £800 per tonne, checking the density and material group. And 5083 at 85p per kilo or £850 per tonne, and again checking the density and material group. All the materials I require have been added and the correct costs have been applied, but you can add as many materials and grades as you want at this point. SigmaNest can cost on either the true shape, which is based upon the part's actual geometry and calculating the exact material used, or the rectangular cost, based on the smallest rectangle needed to create that part. Looking at the part that we've got on screen, we've got a 100 by 100mm rectangle with a 50mm diameter hole going through. You can also see it's made from mild steel with a thickness of 10mm. For this part, the rectangular area will be 100mm times 100mm, which is 10,000mm squared, and the true shape area will be the 10,000mm squared minus the area of the circle, which is 1,963.495mm squared, giving a true shape area of 8,036.504mm squared. Knowing the area, material thickness and density, we can work out the expected mass. Area times thickness times density per kilo will give a rectangular mass of 0.785 kilos and a true shape mass of 0.6309 kilos. Opening the SigmaNest part parameters, we can check the calculated values. When we switch to the cost tab, you can see the net weight represents our true shape weight and, as expected, is 0.6309 kilos. The rectangular mass is also calculated. With the material set to mild steel, we also have the correct price of £1 per kilo applied. This gives us 63p for the true shape and 78p for the rectangular shape. Changing the material will quickly update the cost value. Let's change to S275JR, which is set to 50p per kilo. The cost is changed to reflect the price set in the material database. Changing to any material will update the cost to the values set in the material database. SigmaNest will also let you override these values to add a cost independent of the database. With all of your custom materials set up in the SigmaNest material database, you can always be sure that the material cost will be accurate. The next video in this series will be on setting the operating costs in SigmaNest and this will show you how to add your machine operating costs to the costing process.